Hello class, and welcome to Note 6.6, Direct Variation. We have two standards that you need to write down today, AF 3.4 and AF 4.2. Our objective today is to understand direct variation. What direct variation is it's simply slope-intercept form without the y-intercept. Unfortunately, they use a different formula, y equals kx. And the k is in the m spot, but they both mean slope. We call it the constant. So the k stands for the constant, the non-zero number k. So when we've got direct variation, we don't have a b. So you can see here I've subtracted the b off. And the reason is if there's no b, that means the b would be 0, meaning the y-intercept must be 0. So it has to cross at the origin. And then the k is the constant, it's the slope. So it's how much your line is angling up or down. Okay, so let's go ahead and take a look at some of these using our formula. Teacher example 1. Tell whether the equation represents direct variation. If so, identify the constant or what's in the k spot, the slope. So first, I need to change this problem around so it matches my formula of y equals kx. So obviously I need y by itself, so I need to move this negative 2x. So I start by adding 2x to both sides. 0 plus 2x is simply 2x. And now I want to see if it matches up with my formula y equals kx. And in fact, it does. So yes, it does represent direct variation. And the number that's in the k spot, the constant or the slope, is 2. So my answer would be yes, and k equals 2. Number 2, we have a problem here where again I need to move the negative 2x just like in the last problem. So I add 2x to both sides. Now I want to remind you, we've been going over this all year, but you cannot add 3 plus 2x because they are not like terms. They don't have the same variable. So I end up with y equals 2x plus 3. Now when I try to match it up with my formula, I've got my y, my equals, my k, and my x. But remember, my formula stops at x. There can't be anything after the x. In this case, there's a 3, a plus 3. So that means this is not direct variation. It's slope-intercept form, but is not direct variation. It will not go through the origin. Remember, anytime you have direct variation, it will go through the origin. There will not be a b on the end here. Okay, so I'd like you to go ahead and try these out. Again, get them in the formula, y equals kx. If you can, please identify the constant. If you can't, you just say no. Okay, let's see how you did. I want to start by adding 3x to both sides. 9 plus 3x, as we know, I can't combine those. So I leave it as y equals 3x plus 9. Now I can't get this to match my formula because I have a plus something on the end. Remember, my formula has to end with x. So my answer is no. Here I add x on both sides. And of course I don't need the 0 anymore, so just y equals x. And this one is a little tricky. Some of you might have said no because you thought there wasn't a k. But what number can I plug in here that would be the same thing as just saying I have a x? And of course that number is 1. So my answer is yes, and the k is 1. Okay, tell whether the table represents direct variation. If so, write the direct variation equation. Okay, it's a little different. One option that you have is to graph your table and see if it passes through the origin. If it does, and if it doesn't have a slope of 0, meaning it wouldn't be lying right on the x-axis, then it does represent direct variation. So if you'd like to graph, that might be the easiest way. If not, we want to determine the ratios of x and y are constants. So remember, we always do the rise over the run. This is the tricky part for a lot of students, is the y is your numerator, the x is the denominator. So a lot of students try to write 1 over 6, and that's not correct. It would be 6 over 1. So what I want to do is I want to pick 2 of these ordered pairs, any 2 you want. I tend to choose smaller ones because they're easier to work with, but I also tend to choose positives because they're also easier. So I might do 6 over 1 compared to 2 over 10. So I want to simplify both my fractions. 6 over 1, of course, reduces to the whole number 6. 10 over 2, they're both divisible by 2, which would be 5 over 1, which would simplify simply to 5. 6 is not equal to 5, so my answer is no, it is not direct variation. Problem number 2, again, I'm going to pick any two of them. I can choose any two I want. I can do 4 over 1 and compare it to 20 over 5 if I want. But again, I tend to choose the smaller ones just because they're easier. Okay, I want to simplify my fraction. 8 and 2 can both be divided by 2. 4 over 1 can be reduced to 4. And 4 does equal 4, so my answer in this case is yes. And my constant is whatever it reduced to. And this is where it's so important that you have your fraction right side up. If you had it upside down, your answer would have been y equals 1/4 x, and that would be incorrect. So remember, your slope is always your rise over your run. So go ahead and try these out, doing the same thing. Remember, you want to determine whether the ratios of x and y are constant. So you want to find that slope, rise over run. Go ahead and do so now. Press play when you're ready to see the answers. Okay, let's see how you did. Depending on which ones you chose, you could have chosen any of them, but you would have gotten the same answer. Both fractions would have reduced down to 6. So 6 does equal 6, so of course my answer is yes. And my formula, my equation following the formula of y equals kx would be y equals 6x. Number 4, pick any of those, reduce my fractions, and there's nothing I can do really. I can reduce this one. This one would just be a mixed number if I tried to reduce it. So obviously my answer is no. So go ahead, try these problems out, tell whether the equation represents direct variation. Remember, you're trying to get it in the form y equals kx, ending at x. You don't want anything after x except, of course, a 0, because a 0 wouldn't do anything. Okay? So your answer is simply yes or no. And I believe in Schoology it says true or false. Have a great day.